Have you ever looked up at the night sky, wondering what secrets it might hold? It's easy to feel small beneath the sprawling canvas of stars, but those twinkling points of light are only a tiny part of a much greater mystery. We tend to think of the universe as something vast, an endless expanse of stars and galaxies that stretches beyond our comprehension. Yet, despite our advancements in technology and science, what we see through our most powerful telescopes is only a sliver of what truly exists. The universe is so much bigger, and there are strange phenomena, hidden mysteries, and even massive structures that might lie just beyond our reach, waiting to be discovered. In fact, some scientists believe that something truly enormous, something unimaginable in its scope, is out there, something so massive that it might even be influencing the very course of our own universe. But what could it be? And why haven't we noticed it until now? What if I told you that our understanding of the universe is more restricted than we think? That, despite our best efforts, we're essentially looking through a narrow window into an unfathomably vast cosmos? This isn't a flaw in our instruments or a gap in our knowledge, it's simply the way the universe works. The universe is vast beyond measure, and our ability to observe it is limited by several factors, most of which we can't control. When we peer into space, what we're really looking at is just a small slice of the whole picture, defined by the limits of the observable universe. This doesn't mean that the rest of the universe doesn't exist, it just means that we can't currently see it. The observable universe refers to the part of the universe from which light, or other electromagnetic radiation, has had enough time to reach us since the Big Bang. The universe is estimated to be around 13.8 billion years old, which would suggest that the observable universe is around 13.8 billion light-years in diameter. But there's a catch, because the universe has been expanding since the Big Bang, the objects that emitted that light are no longer where we see them today. The universe isn't static, it's constantly expanding, meaning that the distance between objects is increasing over time. In fact, the observable universe's actual size is closer to 46.3 billion light-years across, a mind-bogglingly large distance that stretches far beyond our previous assumptions. This means that when we look at distant stars and galaxies, we're not seeing them as they are today, we're seeing them as they were in the distant past. Light that left a galaxy billions of years ago is only just now reaching us. So, every time we look at the night sky, we're actually looking back in time. We're peering into the history of the universe, witnessing the events that happened long before our planet was even formed. And yet, despite all our advances in astronomy, our view is still limited. We can only see as far as light has traveled, which means there are vast regions of space that we will never be able to observe directly. But what if there's more to the universe than we can see? What if there are enormous structures, perhaps even entire universes, just beyond the limits of our perception? It might sound like science fiction, but there's growing evidence that something strange is happening at the edges of our observable universe, something that could hold the key to understanding the deepest mysteries of space itself. The universe, as we know it, is not only vast but also isotropic. This means that it looks the same in every direction, at least from our perspective. The distribution of galaxies and cosmic structures is remarkably uniform when we observe the universe on large scales. This uniformity suggests that the universe is well organized, and its evolution follows a predictable pattern. However, in recent years, scientists have discovered some intriguing anomalies that don't quite fit into our established models of cosmology. These anomalies suggest that there may be a larger, more complex structure at work, something that could be influencing the very fabric of spacetime itself. One of the most intriguing discoveries came from NASA's Wilkinson Microwave Anisotropy Probe, WMAP, which was designed to study the cosmic microwave background, CMB, radiation, the faint afterglow of the Big Bang. This radiation fills the entire universe and provides a snapshot of the universe's early conditions. As researchers examined the data collected by WMAP, they noticed something strange, a peculiar, large-scale anomaly in the way the universe's galaxy clusters were distributed. Instead of the expected random distribution, there appeared to be an enormous, uniform cosmic flow, a stream of galaxy clusters moving together in the same direction. At first, this seemed like an error in the data. After all, the movement of galaxies should be random, according to the standard model of cosmology. But after further analysis, scientists were forced to reconsider their assumptions. The strange cosmic flow didn't appear to be caused by any known structures within the observable universe. The galaxies were not moving randomly, they were all moving toward a common point, and the flow seemed to extend far beyond the observable universe itself. This was something entirely unexpected. The researchers concluded that the only plausible explanation for this anomaly was the existence of an enormous, unseen structure, one that was exerting an immense gravitational influence on the observable universe. So, what could this mysterious force be? Could it be a massive object lurking just beyond the edge of the observable universe, exerting its gravitational pull on everything within reach? Or could it be something even more bizarre, a region of spacetime where the laws of physics behave differently, perhaps caused by the influence of another universe or an alternate dimension? The possibilities are mind-boggling, but one thing is clear: something is pulling on the universe from beyond our view, and it's changing the way we think about the cosmos. In fact, the more scientists studied this phenomenon, the more convinced they became that this was no mere fluke. Over the course of several years, the data from WMAP and other telescopes confirmed the existence of this strange cosmic flow. Even more fascinating, the speed of this flow increased with distance, suggesting that whatever was driving it had a powerful gravitational influence that grew stronger over time. But here's the catch: this flow was moving toward a point that lies outside the observable universe, beyond the limits of what we can currently see. This presents a major challenge for cosmologists. How do we study something that is located beyond our field of vision? Some researchers have suggested that this mysterious flow could be the result of a massive cosmic structure, perhaps a galaxy cluster or supercluster, located beyond the edge of the observable universe. Others have proposed more exotic explanations, such as the existence of another universe or even the presence of strange, unseen objects that are hidden in the vast emptiness between galaxies. There are also theories that suggest that this anomaly could be the result of a rip in the fabric of spacetime itself, where different regions of the universe are interacting in ways we don't yet fully understand. The leading researcher on this topic, Dr. Alexander Kashlinsky, has been vocal about the implications of this discovery. He argues that the evidence strongly suggests the existence of a massive structure beyond the observable universe. However, the question remains: what exactly is this structure, and what could it mean for our understanding of the universe as a whole? Kashlinsky has speculated that this could be the result of an entirely different cosmic phenomenon, one that challenges our current understanding of the laws of physics. He has suggested that it could be a distant superstructure, or perhaps even an entirely separate universe that is interacting with our own in ways that we don't yet understand. The implications of this discovery are profound. If this cosmic flow is indeed being caused by a structure located beyond our observable universe, it could suggest that there are vast regions of space that we are unable to observe, regions where the laws of physics might operate differently, or where entirely new forms of matter and energy could exist. This would mean that our understanding of the universe is far from complete, that we're only seeing a fraction of what's out there. Of course, not all scientists agree with this hypothesis. Some have argued that the dark flow is simply an artifact of our observational techniques, or that it could be explained by previously unknown factors within the observable universe. A subsequent study by other researchers found no evidence for a large-scale cosmic flow, casting doubt on the validity of Kashlinsky's findings. These scientists argue that the apparent movement of galaxies could be the result of local gravitational effects, rather than an external influence. They also point out that the data may have been misinterpreted, and that more research is needed before any conclusions can be drawn. Despite these critiques, the mystery of the dark flow persists, and the debate continues to evolve. Some believe that the anomaly could be a sign of a more profound truth, that there is something beyond the observable universe that is influencing the very fabric of space-time. Whether this means we're dealing with another universe, a hidden cosmic structure, or something else entirely, one thing is clear: the universe is far stranger than we ever imagined. But what does this all mean for the future of cosmology? If there really is a hidden force at work beyond the observable universe, it could change everything we know about space, time, and the nature of reality itself. It could open the door to new theories about the structure of the universe, the possibility of other dimensions, and even the existence of parallel universes. In fact, some physicists have speculated that this dark flow could be evidence of the multiverse, a vast, infinite collection of parallel universes, each with its own unique properties and laws of physics. In the multiverse theory, every possible version of reality exists, and our universe is just one of many. This idea may seem far-fetched, but it's one that has gained traction in recent years, particularly among proponents of string theory and other advanced models of physics. According to string theory, the universe is made up of tiny vibrating strings that exist in multiple dimensions. These strings interact with one another in complex ways, and when they collide, they can create new universes. In this framework, the multiverse is a natural consequence of the laws of physics. Each universe within the multiverse could have its own set of physical constants, and it's possible that some of these universes might even have completely different laws of physics from our own. The dark flow, then, could be a glimpse into this vast multiverse, an indication that our universe is just one bubble in an infinite cosmic ocean. If this theory is correct, it could mean that there are countless other universes out there, each with its own unique version of reality. Perhaps there's a universe where the laws of physics are completely different, where gravity doesn't work the way we know it, or where life takes forms we can't even imagine. For now, the mystery of the dark flow remains unsolved, and we are left with more questions than answers. But one thing is certain, the universe is full of surprises. Even though our view of the cosmos is limited, we're constantly making new discoveries that challenge our understanding of space, time, and reality itself. Whether we're dealing with hidden structures, parallel universes, or something even more bizarre, the search for answers will continue to push the boundaries of science and our understanding of the cosmos. The quest to uncover the secrets of the universe is just beginning, and as our technology advances and our theories evolve, who knows what astonishing revelations lie ahead. If the dark flow truly represents a new frontier in our understanding of the universe, it's only a matter of time before we break through the barriers of the known and discover the unfathomable mysteries that lie just beyond our reach. And when we do, the universe will be forever changed.